Now I will talk about graphical meaning of the average rate of change. So, graphical meaning of the average rate of change. Graphical, so we assume that the graph of the function is given. Graph y equals f of x, and graph always starts with y equals. So this graph is given. For example, the given graph looks like this. This is the origin, this is the x and y axis, and the graph of the function looks like this. Y equals f of x. And let's say that the interval also given on which we want to calculate the average rate of change. So the interval stretches from a to b, so we're talking interval a, b. So let's say this is my a, this is my b, and this is the entire interval, a to b. Now here's what I want to do. For this point, I want to find the corresponding point on the graph. And now, since it is located right above this point, with coordinate a, so the x coordinate of this point is a. I remind you, every point on the coordinate plane has two coordinates, the x coordinate and the y coordinate. Now, the x coordinate of this point is a, blue, so a, because it's located above the a, and the y coordinate can be calculated from here because this point is located on the graph. So y equals f of x, but since x coordinate is a, so it's f of a. Similarly, I can find the other point which is located above the end of our interval. And similarly to the first point, the coordinates of this other point on the graph can be found like this. So the x coordinate is b, and the y coordinate from this formula is f of b. So we have 2 points on the graph, and the next thing I want to do, I want to connect these 2 points with a straight line. And I want to make this line infinite by stretching it both ways. This line has a special name. In mathematics, it's called secant line. In fact, the word secant is a Greek word. There are many Greek words used in mathematics. Specifically, the word secant means intersecting. And indeed, this straight line intersects the graph of the function. It's supposed to be straight. My picture may not be perfect. But it crosses the graph of the function at 2 points. So indeed, it crosses or intersects the graph, and that's why it's called so secant line. Now, why do I need secant line on this picture? Because the next thing I want to do, I want to calculate the slope of the secant line. Now, I will remind you that slope of any line So if there is any line on the coordinate plane, let's say this line that passes through 2 given points, let's say coordinates of the first point are x1, y1, and the coordinates of the second point are x2, y2, then there is a simple formula to calculate slope. Typically, slope of this line is denoted by m. So slope is, I remind you, slope is the quantity that measures how sharply this line goes up or down. So this measure of sharpness can be expressed with a number precisely, and specifically when you have coordinates of 2 points on the line, there is a simple formula for the slope, and that is y2 minus y1 over x2 minus x1. Now I want to apply this same formula specifically for the secant line. This formula is general, it applies to any line passing through 2 points with known coordinates. But right now I want to apply this formula specifically in this case, when this is my x1, this is my y1, this is my x2, and this is my y2. And so, if I plug in everything into general formula for the slope, so this formula becomes f of b minus f of a over b minus a, which is precisely the same formula that was previously introduced as average rate of change. So this is the same as the average rate of change. So here is the graphical meaning of the average rate of change, that the average rate of change equals slope of the secant line. So average rate of change of a function over a certain interval equals slope of the secant line. Going through the, or crossing these graphs through those 2 points corresponding to the beginning and the end of this interval.